Good morning, everyone. Hi, I'm a couple minutes late. Sorry about that. I wasn't paying attention to the clock. I noticed last week that I had already gotten started really before people joined. So we're going to give people a few seconds to find the video and to join us. So we're just going to hang out for a little bit. And what I want you to do while we're just kind of hanging out for this first little bit is comment below and let me know if there are any projects that you want to see. And if you do one of our projects, we would love for you to tag us on Facebook. So you can tag Washington Carnegie Public Library. You can come onto our Facebook page and you can post your picture on there and just put #STEM, #STEM at WCPL. That way we can see these projects that you're doing with us, okay? I've got some wild hair this morning. The baby's upstairs, so if you hear any crying, I'm so sorry. This is what working from home really is, guys. All right. Good morning, Matthew. Good morning, Elsie. And the girls are watching upstairs. Good morning, Addison and Ashlyn. Good morning. Okay, so we've got a few people joining us, so I'm going to go ahead and get started. And remember, you can always go back. I'm going to link all of the projects that we did in the comments. You can always go back and restart this video and watch the projects from the beginning. Now, I'm going to do the same thing I did last week, so half the time you're going to see me and half the time you're going to see the projects. It's just the best way to do it. That way everyone can see kind of what's going on, okay? So the first thing that we're going to do is what we started on last week. Do you remember what we did last week? Good morning, Ethan, Lily, and Emma. Good morning. Thanks for joining us. We did our egg in vinegar last week. So we covered it in vinegar, we put it in a jar, we sealed it up, and we didn't touch it. Good morning, Bryant and Caroline. We didn't touch it all week, right? We just let it sit. Did you notice anything with your egg while it was sitting this week? I noticed some stuff with mine. So my egg had bubbles on it, and yesterday I really noticed that it had some film on the top of the jar, on top of the liquid. Do you have any idea what that could be? We're going to figure out. So I'm going to flip you around. Let's flip you. Okay, so as you can see in front of you, I've got all my supplies. This is my supply area. And this is a regular egg. So it's white, it's got the shell, it's really hard. We did an experiment with the STEM lab to see if we could break an egg just by squeezing it. So if you want to do that, if your parents will let you, all you have to do is hold it in the middle of your palm and try to squeeze it, and you can't break it because it's so tough. I can't break it. Maybe you can. You want to make sure there are no cracks in it before you try to do that, just because any breaks in the structure will make you be able to crack it. But you cannot squeeze an egg. This is the egg's protective coating. So what we did with the vinegar is we removed that coating. Can you see that? Look how cool that is. So this is an egg without any shell, and that's what our vinegar did. So our vinegar stripped away that shell, and we soaked it for 1 week, and I poured out the vinegar this morning and I rinsed it with water. I rinsed off any remnants of that shell. So before you do this, you'll want to make sure you rinse it. Okay, because you don't want vinegar all over your hands. And it smells a little gross when you do it, just a forewarning. So the only thing we have left is the membrane. I'm going to flip you around so I can talk to you. So all we have left on this egg is the membrane. So an egg has a semi-permeable membrane. I know that's kind of a big word. But what it means is that some things are allowed to pass through the membrane and some things are not. So our vinegar was allowed to pass through the membrane once we removed the shell. So if you can see the difference in my eggs, see how much larger this one is that we soaked in the vinegar? The vinegar went into the egg through the process of osmosis. And osmosis basically means that the water outside, or the vinegar in this case, wants to equal the water inside the egg, and so it flows through that semipermeable membrane so it'll be equal. So we had lots of vinegar around our egg, so it soaked up a lot so that it could try to be equal with the vinegar that we had outside. Now you can squish it. I will forewarn you. I'm going to move my other egg back. I'm going to warn you that I had to borrow my sister's egg this morning because I dropped my egg and it busted everywhere, guys. It really did. It was that kind of morning working from home. It busted everywhere. So this egg you're going to be a little bit gentle with because it has no hard coating on the outside to protect it, okay? So you can kind of squish it, and if your parents will let you, you can break it open and see what's inside. And it'll be really cool when you break it open. You can slice it with a knife, or you can just pop it, and you can see what's inside because it still looks like a regular egg on the inside, but doesn't the outside look so different? And you can see the yolk in there. Isn't that cool? Okay, so that's our egg. We're going to move this to the side. Get that out of the way. We're done with this one. All right, so our next project, we're going to do some disappearing cups. So I'm going to flip you back around, and I've just got a bowl right here, and it's got some liquid in it. I'm not going to tell you what the liquid is yet. I want you to try to guess. And I've just got a regular styrofoam cup, and you can use any styrofoam for this, but I've got cups. Now remember, with this quarantine chemistry, we're using whatever we have at home, okay? So you don't have to try to fight people at the grocery store to go out and buy stuff. Any sort of foam that you have at home, packing peanuts, foam plates will work for this, okay? So here's what I'm going to do. I'm going to push it in. Can you hear that? As you can see, my cup is disappearing. Now, you know we put all sorts of liquid in foam cups, right? Foam cups are great for coffee. They can hold hot liquid. They can hold cold liquid. So what would be strong enough to completely get rid of that cup, guys? Well, the answer is acetone. So this is just nail polish remover, and I put a little bit on the bottom of my bowl, and then we just use the cup and we suck it in. I'm going to flip you back around. Now, because styrofoam is a polymer, do you remember we talked about polymers last week? They're those long chains of repeating chemical units. It's a polymer that is injected with air. So the cup is super lightweight, right? You can throw it around, it gets caught on the breeze and it flies away if you're at a picnic and it has no liquid in it. So the injected air is about 95% of what the cup is made up of. So when you put the cup in the acetone, it breaks those polymers. Remember last week, the bag wanted to stay together. Polymers want to stay together. But this one can't stay together because of the acetone. As soon as it touches those polymers, they break apart, and then the rest is air. So it just dissolves into nothing. Let's try that again, okay? So all you need for this one is just a container, some nail polish remover, and something foam. Like I said, I just used a cup because that's what I had. Don't rush out and buy anything special just for these projects. We're working with the stuff that we've got here. All right, we're going to let that dissolve. So you see those bubbles that are coming up? That is actually carbon dioxide. Carbon dioxide is forming from this cup. So it makes those bubbles. It's really fun. That one's a really fun project. And you can swirl it around and see on the bottom, it's kind of got some gunk left. Those are those polymers. So that is what your cup is actually made of, and the rest is air. It's just these long strands of polymers. All right? So now we're going to do a dry erase drawing. Flipping you around again. I know this is kind of like back and forth. So last week we said we were going to make a stick man dance. Have you guys ever done that before, or have you seen the video? There's a video that went around Facebook that's so cool of a stick figure that's actually dancing, and we're going to do that. Now, I'm not good at drawing stick figures, so I'm going to draw something else, but we're still going to make it dance, okay? So what you need for this one is a smooth plate, a dry erase marker, and some water, and maybe a straw if you want to. And that's completely up to you. If you don't have straws, that's no big deal, okay? So we'll flip you around. And you can see I've just got a regular plate. You can use a glass dish. You can use a baking pan. You can use any sort of thing. This dish just seemed to work out pretty well, and it's what I've got on hand. So I'm going to draw some hearts. Probably should have drawn these before, but that's okay. This is live, right, guys? We're doing everything together. All right. And I completely forgot my water. I will be right back. Okay, guys, it's a good thing I do this in my kitchen because I completely forgot to grab my water. Okay, so we're just going to pour some water. We're going to pour it right on the edge, okay? Just pour it around the edge. Make sure you've got kind of a thin layer of water on there, okay? And now I'm going to take my straw and I'm just going to blow on this. You need a lot of hot air for this project, guys. You don't have to blow on it, by the way. If you don't have a straw, just twirl your plate around, okay? Just that water needs to be moving. Can you see what's happening? I hope you can see it on the screen. You see the hearts are moving? So, how did we do that? Dry erase marker is actually made up of, let me flip you back around. The dry erase marker is actually made up of a polymer. Polymers are everywhere, guys, and they're one of my favorite things in chemistry. So this one is actually an oily silicone polymer. Basically what that means is it doesn't stick to surfaces when you write on it. So, yeah, you should be a pro at this one. So, when you write on a whiteboard with a dry erase marker, you want it to come right off, right? When your teachers write on dry erase boards, you just want to be able to erase that right off. Now, if it didn't erase off, it would be more like a permanent marker, and then there wouldn't be any point in using them. So, because this is made of that oily polymer, when you think of oil, you think of kind of slippery. We can put water on it, and because it's actually less dense than the water, it floats up to the surface and it has buoyancy, and buoyancy just means that it floats on the water, and so we can actually draw and make our picture come to life. I'll flip it around a little bit so you can see it. So see that? A little more of mine have come up. I'm sure you guys are way better at drawing than I am. I wish I could tilt this to the side so you could see it. Maybe let me move this. We're going to do this in real life, guys. See, my hearts have kind of come apart a little bit, and one of them just doesn't want to pull up. But you can draw a stick figure on here. Last night I did one, and the stick figure's hand was waving, and it was so much fun. All right, let me put you back on my stand. You're going to see behind the scenes of this one, okay? All right. So I've got one last project for you guys. So this week we did 4 projects, and next week we'll have a few more, okay? but you don't have to prep anything for next week. So this one, we're actually going to use a non-Newtonian fluid. Now, if you've heard of Newton, he's a huge scientist, and what non-Newtonian means is that it actually doesn't follow his laws of a liquid. So, I know that's a lot of big words, but Newton came up with a lot of laws. He's got his laws of gravity and motion and liquids. So, it all deals with viscosity. Now, viscosity means how fast or how slow a liquid flows. So molasses, when you try to pour it, is super slow, right? But water, the water I just poured right now, was actually really fast. And then dish soap is about somewhere in the middle, right? So we are going to make something that is, when you put force on it, it's hard. But when you let it go, it flows, and that's called oobleck. Have you played with oobleck before? It's just water and cornstarch. Now, I don't have any oobleck right here because I turned it into this non-Newtonian putty. Can you see that? See how it's got a really nice texture? And when you press on it, it gets kind of soft, but it also pulls apart when you force it. So, this is oobleck with dish soap. So, all you have to do is get some dish soap. It doesn't matter what brand. I have this giant container, and it's just like off-brand dish soap. You can use that. You're going to need 1.5 tablespoons of dish soap, okay? And then you're going to need 2 tablespoons of cornstarch, all right? So just any brand. Again, I'm just using what I have on hand. So you're going to mix those together. You're going to start mixing them with the spoon, and then you want to knead it, kind of like bread, and you really want to work it, and you're going to get a nice putty. Now, you can change how much of the ingredients you're doing so that you can get more putty. This is how much you get with 1.5 tablespoons of the dish soap and 2 tablespoons of the cornstarch, okay? And this happens because the non-Newtonian fluid doesn't act like a liquid and it doesn't act like a solid. And dish soap has water in it as well. So basically what we're telling it to do is still be non-Newtonian, but stick together a little bit more, okay? So what would be really fun is to make some oobleck and push on it and pour it and see what you can do with it, and it's just water and cornstarch. And then go ahead and make this. That way you can see how it behaves in its oobleck form, and then you can make your putty. And this is really fun, and parents, it's not sticky at all. You can see my hands are clean from messing with it, and it just pulls apart. It feels so nice. It's so fun, and it smells like soap. And because we all need to keep our hands clean at this time, you can wash your hands. Just keep them clean with the soap, right? Okay, so by the way, ketchup is a non-Newtonian fluid because it is runnier after you shake it. Have you ever tried to pour out ketchup and it won't come out, and then you shake it and it does come out? Non-Newtonian fluid, because it reacts differently under different circumstances. Okay, so this was kind of a hot mess. I'm sorry, we're live. This is what working from home is. I hope you have fun with these projects. I hope you try a few out. I hope you post pictures on the Washington Facebook page and let us know how it went. And next week, we're going to do some more projects, okay? And it's going to be really fun. So thanks for joining me, and I hope you have a really great time in isolation, and hopefully I get to see you guys soon. Thanks for joining.